Deep inside giant molecular clouds, expanses of freezing, dense gas, gravity initiates an inward collapse. As this material crushes together, the friction and pressure cause the core temperature to spike immediately. This diagram shows a strict cosmic threshold. If the collapsing clump of gas gathers less than 8% of our sun's mass, the core temperature stalls out. It never hits the 3 million degree mark required to ignite stable hydrogen fusion. The result is a brown dwarf. It manages a brief period of burning rare isotopes like deuterium, but the object cannot sustain the reaction. It steadily cools, eventually forming thick atmospheric clouds of silicates and ice. Without the sheer mass to jumpstart a nuclear engine, gravity wins the early battle. The object becomes a failed star, fading entirely. If that collapsing pocket of gas exceeds the 8% mass threshold, the core becomes so hot and dense that hydrogen atoms are forced to slam together. The main nuclear engine ignites. This diagram illustrates hydrostatic equilibrium. The inward crush of the star's own gravity is perfectly met by the outward explosive pressure of the nuclear fusion in its core. Entering this phase, the main sequence, means a true star is born. The initial starting mass immediately programs the script for its lifespan and death. This period of stability is a violent, temporary stalemate and an ongoing thermodynamic war. In the mass destiny matrix, greater mass provides more fuel but exponentially decreases a star's lifespan. These massive objects must consume their resources at a furious rate just to hold off the extreme weight of gravity. Low-mass stars, like our Sun, process fuel through the highly efficient proton-proton chain. They burn their hydrogen slowly, staying on the main sequence for billions or even trillions of years. This animation shows the structural collapse once helium ash builds up. The core begins to shrink under gravity, which raises the temperature and forces the outer layers to blow outward and cool, creating a red giant. Eventually, the outer layers drift away. Gravity tries to crush the remaining core, but it hits a quantum wall, a phenomenon called electron degeneracy pressure, where subatomic particles resist being squeezed into the same state, abruptly halts the collapse. The surviving remnant is a white dwarf. It is an Earth-sized, incredibly dense sphere of glowing carbon and oxygen that will slowly crystallize and fade into darkness over trillions of years. For these lower-mass stars, an obscure rule of quantum mechanics provides a permanent defense against gravity, leaving behind a frozen, immortal ember. Up on the high-mass branch, extreme gravity forces the hyperactive CNO cycle. This process burns so fiercely that the star exhausts its entire hydrogen supply in just a few million years. Notice how the internal structure changes. As fuel depletes, the star survives by fusing progressively heavier elements, carbon, oxygen, silicon, in concentrated layered shells, like an onion. But this process hits a fatal limit at the very center. The fusion of iron absorbs energy rather than releasing it. The moment iron is forged, it instantly kills the core's outward pressure. Without that outward push, gravity crushes the core at a fraction of the speed of light. The outer material crashes into the dense center and rebounds, ripping the star apart in a spectacular supernova explosion. For the most massive stars, extreme weight is a death sentence, ensuring their own internal fuel mechanics eventually betray them. Once the supernova dust clears, we reach the final branch of the matrix, dictated entirely by the mass of the dead core left behind. If that remaining core is under 3 times the mass of our Sun, the extreme pressure crushes protons and electrons together. The result is a neutron star, an ultra-dense, rapidly spinning sphere of pure neutrons. This logic tree shows the ultimate divide. If the core exceeds 3 solar masses, no quantum force can stop the collapse. It shrinks into an infinitely small point, a black hole. Here, gravity achieves absolute victory, warping space-time so severely that light is trapped. At the extreme high end of the mass scale, gravity completely overpowers the thermodynamic war and breaks the standard laws of physics. But the destruction of these massive stars serves a purpose. The supernova shockwave violently expels those newly forged heavy elements back out into the cold expanse of the giant molecular clouds. This branching life cycle is the fundamental cosmic engine. It is responsible for seeding the universe with the complex chemistry required for planets and life. The mass destiny matrix is the literal mechanism of creation that scripts the chemical evolution of the entire cosmos.